This is the fourth video on revision of A-level binomial expansion question and answers. So you're reminded this is aimed at A-level students or people doing maths courses around the age 17 to 18, and our intention is not so much to teach but as to demonstrate how you might solve typical problems that come up in examinations. Now first, however, we need to remind you of the key formula that you're going to use in order to solve those questions. Here we have then. So if we've got a binomial expansion, we're talking about something like a plus b to the power n, and we know that can be written down as a to the power n plus some coefficient times a to the n minus 1b plus some other coefficient times a to the n minus 2b squared, and so on. And what we need is these coefficients. Well, we've shown earlier the first coefficient, f1n, is given as n. The second coefficient, f2n, is given as n times n minus 1 over 2. The third coefficient, f3n, is given as n minus 1, n minus 2 over 6. And if you need it, the general expression for the rth coefficient is n factorial over r factorial times n minus r factorial. And what I would say is, when you begin a question, always write down these formula first. However, a little aside, you might say that writing down all of these is a bit tedious, and why not just substitute this straight into here and then substitute this coefficient straight into here. So generally, if it were me, I would probably just write down this single formula here, that a plus b to the n is a to the n plus n a n minus 1b plus, and then you can see the second coefficient is straight in the formula, and so on. Questions then. So write down the first three terms in ascending power x of 1 plus px to the power 12, where p is a non-zero constant. And having done that, given that in the expansion the coefficient of x is minus q and the coefficient of x squared is 11q, find the values of p and q. So how would you do this question? Well, a reminder of the technique. The first thing you do is write down the key formula you're going to use. Before anything else, before you start, write down the formula first. So that's what we're going to do. You'll see I've repeated part A so you can see it, which is just find the first three terms, and I've said, right, what I'm going to do is just write down the formula that I know. Write it on the exam paper before you go any further. Now as soon as I've done that, I can see that I've got a plus b equals 1 plus px, which tells me that a equals 1 and b equals px. And I can also see, because there's a 12 up there, that n equals 12. So now all I need to do is substitute these three numbers into this formula. So if I do that, I'm going to get 1 plus px to the power 12 is going to be 1 to the power 12 plus 12 times 1 to the 11, which is 1, so I won't write it, so times px, plus 12 times 11 times px squared over 2. And there are more terms, but you'll notice I've only been asked for the first three terms, so I'm going to stop there. Now I can, of course, multiply this out, so I've got 1 plus 12px plus 66 p squared x squared. So there's part A done, and hopefully you'll accept that by writing down the formula first, it becomes relatively straightforward. Okay, next part. Now, you would normally have it because you would be on the same piece of paper, but I'm just going to write down what we got on the previous page so we don't lose it. So what does the question say? Given that in the expansion the coefficient of x is minus q and the coefficient of x squared is 11q, find the values of p and q. Well, these coefficients are clearly here. There's the coefficient of x and there's the coefficient of x squared. So what we've been told is that 12p equals minus q, and we've also been told that 66p squared equals 11q. Now I can simplify this last one by dividing by 11, and I get 6p squared equals q. And what do you notice? I've got a plus q here and a minus q here. So what that tells me is that 6p squared equals minus 12p. I hope that's obvious to you from those two expressions. And having done that, I can take this and I can write 6p plus 12p, sorry, 6p squared plus 12p equals 0, or 6p into p plus 2 equals 0, which gives me p equals 0 or minus 2. Now you remember in the question it told you that p was a non-zero constant, so I can't have that, so I'm going to end up with p equals minus 2. That's the solution I want, and once I've got that, then clearly q must be 24, and you can get q, for example, from that expression there. Next question then. Find the first 4 terms in ascending powers of x of the binomial expansion of 1 plus dx to the power 10, where d is a non-zero constant, and give each term in its simplest form. And once you've done that, you're given the coefficient of x cubed is double that of x squared. Find the value of d. So again, a reminder, what we're going to do is write down the key formula before we start. So let's go to part A then. So this is just find the first 4 terms, and what we're going to do is say this is a binomial expansion question, so let me write down my general expression for a binomial expansion. There, I've done it. So now I can write down clearly that a plus b equals 1 plus dx, which tells me that a equals 1 and b equals dx. And clearly in this case n equals 10. So now all I need to do is substitute these 3 numbers directly into this formula. So if I do that, I'm going to get 1 plus dx to the power 10 is going to be 1, because obviously 1 to any power just gives me 1, plus 10 dx plus 10 times 9 times dx squared over 2 plus, and I better squeeze this in carefully, 10 times 9 times 8 times dx cubed all over 6. So you'll notice it asked for 4 terms, so I've given 4 terms. Now we want these in the simplest form possible, so I've got 1 plus 10 dx. That's straightforward. I'm now going to have to multiply out what I've got in the next one, so that's going to end up as 45 d squared x squared, and then the final one is going to end up as 120 d cubed x cubed. So that's part 1 done. We've got our expression, the first 4 terms. Okay. Next question then. Given that in this expansion the coefficient of x cubed is double that of x squared, find the value of d. So I'll just remind you what we had. We had 1 plus 10 dx plus 45 d squared x squared plus 120 d cubed x cubed. And the 2 coefficients we're talking about are the coefficient of the x squared, that's 45 d squared, and the coefficient of the x cubed, that's 120 d cubed. So what they've told you is that 120 d cubed equals twice 45 d squared. So that's the information given in the question. Just write it down. And as soon as you've written it down, you see, golly, the solution's rather obvious. First of all, I can cancel the d squared on both sides, and so what I get left with is 120d equals 90, or d equals 90 over 120, which is 0.75. And hopefully you see what appeared to be quite a difficult question is actually quite elementary. Next question then. Find the first 4 terms in ascending powers of x in the binomial expansion of 1 plus kx to the power 6, where k is a non-zero constant. And once you've got that, given that in this expansion the coefficients of x and x squared are equal, find k and find the coefficient of x cubed. So, as ever, the first thing we do is write down the key formula before we start. So here's the part A of the question, and as in the previous questions, here's the key formula. So we'll go straight into it. I'm going to write a plus b equals 1 plus kx. So therefore a equals 1, b equals kx, and clearly n equals 6. If I substitute those numbers in, I'm going to get 1 plus kx to the power 6 is going to be 1 plus 6 kx plus 6 times 5 over 2 into kx squared plus 6 times 5 times 4 over 6 into kx cubed. And now if I expand this all out and simplify it, I get 1 plus 6kx plus 15k squared x squared plus 20k cubed x cubed. And again, I hope by now you're saying this part is relatively straightforward. Next bit then. Let's just write down what we had from the previous part, because we're going to need this before we continue. So there's what we solved on the previous page. So what does it say? Given that in this expansion the coefficients of x, there's the coefficient of x, and the coefficient of x squared, there's the coefficient of x squared, are equal, find the value of k. So what we've been told is that 6k equals 15k squared. Clearly I can cancel a k from both sides, so what that gives me is 6 equals 15k, or 6 over 15 equals k, which equals 0.4. And again, you'll see what seemed quite a difficult question you can answer in literally just a few lines. And then it says find the coefficient of x cubed. Well, the coefficient of x cubed is clearly there, so what we're looking for is 20k cubed equals 20 times 0.4 cubed, which is 1.28. You can do that in your head or calculator as you prefer. Question 4 then. Find the first 4 terms in ascending powers of x of the binomial expansion of 1 plus px to the power 9, where p is a non-zero constant. And then the first 3 terms are this: 1, 36x and qx squared, where q is a constant. Find the values of p and q. So as ever, a reminder, start by writing down the key formula that you're going to use. So here's part A, and here's the formula that I'm going to use. So what have we got? A plus b equals 1 plus px, and therefore a equals 1, b equals px, and n equals 9. So I substitute those values in, and I'm going to get 1 plus px to the power 9 equals 1 plus 9px plus 9 times 8 over 2 into px squared, and it's asked for 4 terms, has it? So we need to do the next one. So you're going to get 9 times 8 times 7 over 6 times px cubed. Okay? And of course, if you want those in simplest terms, you've got 1 plus 9px, then you've got plus 36p squared x squared, and then you've got plus 84p cubed x cubed. Okay, so I'm just going to write down the first 3 terms, because that's all we need for this second part, because it says the first 3 terms are given. And what does it tell you about the first 3 terms? It says the first ones are 1, 36x and qx squared. So what we've been told is 9px equals 36x, which tells me that p must be equal to 4. You've also been told that 36p squared equals q. So that tells you, if I put it, that 36 times 16 equals q, or q equals 576. So that's the end, and the next video is going to do questions which are a bit more obscure but do come up from time to time on A-level papers.